Today we're going to look at multiplying decimals, and we're going to start where we can't see any decimals. 2 times 4 is 8, and we know that that's really 8.0, but we don't need the 0.0, it's just 8. So what happens if I say 2 times 0.4? Well, I need to remember 0.4 is just 4 divided by 10. So I can still do my 2 times 4, which is 8, but I'm going to need to divide by 10, which means I'm moving my decimal point one place, and I'm going to have 0.8. 0.2 times 4 works the same way, because 0.2 is just 2 divided by 10, so 2 times 4 is 8, and if I divide by 10, I get 0.8. In the last example, now here we've got 0.2, which is 2 divided by 10, and 0.4, which is 4 divided by 10. So I know that it's going to be something to do with 2 times 4, so I'm going to write my 8 down. Now remember, a whole number has a decimal point at the end of it. I need to divide by 10 for the 0.4. And then I need to divide by 10 again with 0.2, so I'm moving 2 places this time. Which means instead of 0.8, I'm going to have 0.08. Now for each of those, we've been thinking about the number before we started the multiplication and whether it's divided by 10. And we've been doing that division at the end. A quick way to check is to look at the numbers in your original question and see how many numbers after the decimal point. Well, there's no numbers here after the decimal point, which means there's no numbers here after the decimal point. In this question, we had one number after the decimal point, and our answer had one number after the decimal point. Again, in this question, one number after the decimal point, one number after the decimal point. And in the last question, well, we had one number here after the decimal point and another one. So we had 2 numbers after the decimal point. And in our answer, we have 2. You can do much bigger questions than these, much more complicated questions, by following the same rules. Now in these questions, the only multiplication that we needed to know was 2 times 4, which we know from our times tables. Most of the time we can use our times tables. If the numbers are much bigger, we're going to need to use a long multiplication. And we do that the same way we normally do a long multiplication. And then we'd look at the decimal points afterwards. Let's have a look at one example like that. We're going to do 2.56 multiplied by 7.3. Now, because I've realised I can't do this with my times tables, I'm going to lay it out vertically. And then I'm going to carry out the multiplication as I would normally, and I'm not going to think about the decimal points until the end. So 3 times 6 is 18, 3 times 5 is 15, plus the 1 is 16, 3 times 2 is 6, plus the 1 is 7. Second row, I'm remembering to put my 0 in. 7 times 6 is 42. 7 times 5 is 35, plus the 4 is 39. 7 times 2 is 14, plus the 3 is 17. Then I'm going to add those rows together. 0 and 8, 6 and 2, 9 and 7. 7 plus the 1 I've carried, and I get 18688. But wait a minute, I need to go and look at my decimal points. I've used 256 times 73, but 2.56 is actually 256 divided by 100, and 73 is 7.3 divided by 10. So I've got 1, 2, 3 digits after the decimal point. So here I'm going to have 1, 2, 3 digits after the decimal point. So I'm going to put the point right in there. When you're doing questions like this, another useful thing to do is to estimate. So 7.3 and 2.56. If I just did 7 times 2, that's 14. It's close to 18. It's a lot closer to 18 than it is to 186, which would be the next choice. So just do a quick double check. Does that make sense? And then that's our final answer.